All right, so trig functions and graphing them is what we're going to talk about. And sine and cosine, well, actually, all the trig functions are what we call periodic functions. Periodic functions means that the values repeat over time. Now, this is they're also called circular functions, and this is based on the fact that we're drawing these right triangles inside of a circle on the xy plane. So a function f is called a periodic function if there is a positive number p such that f of x plus p is the same as f of x. In other words, the values repeat themselves, and I'll show you that in a second. For all x in the domain of f. So there's a repeating pattern where the y values, which is the same as f of x, just repeat over and over and over. The period in which they repeat we'll call p. That's called the fundamental period. Now, on an untransformed sine function and or cosine function, the period is 2 pi. So just kind of jot that down in your notes. Just put 2 pi for now we can change that by doing some math, but if you just say sine of theta, cosine of theta, the period is 2 pi, and I'll show you all that in a second, okay? So then, let's talk about sine. So sine, the sine function f of x has a domain that goes from negative infinity to positive infinity, all right? So jot this down too. That's all real numbers. There is no domain restriction for either sine or cosine. Okay. However, the range is limited. It never goes past 1 and never goes below negative 1 unless you transform it. It is symmetric about the origin. It is definitely an odd function because it's symmetric about the origin. And remember that odd function sine of negative x is the negative of sine of x. So this value here is a positive f of x. And then if I go in the same direction, which is the negative f of x, in other words, f of negative x equals a negative f of x. It's the same value, but the negative y value. So remember that f of x, you guys got to kind of get used to thinking of f of x as the same as y with regards to value in the two-dimensional plane. So then the sine function is a periodic function with a fundamental period of 2 pi. Okay? And so what that means is that there are x-intercepts that occur at multiples of pi. Okay? So what they mean by that is the halfway point of that period is pi. That's where it's going to cross the x-axis in your and this is the parent function. So write that down somewhere on your notes too. Now, whenever we use the term parent function, if you recall from your Algebra 2 days, that's the most basic, simple version of the function. We can transform the function to make its shape fit any data that's out there. So the maximum value of 1 and the minimum value of negative 1 occurs at pi over 2. And I'll show you in a second when we're done with sine and cosine why that occurs the way that it does. Okay? So let's do one more thing. Let's talk about cosine. Now cosine is the cofunction of sine. And really what it is it's just shifted over pi over 2. Okay? So that changes the numbers a little bit. Again, the domain, and we're talking about the parent function. Remember, parent function is the most basic function. Okay? Remember that the domain is all real numbers. There are no restrictions for x. I can plug anything in for x I want to. However, the range is limited. Same thing. It goes from positive 1 to negative 1. Okay? It is an even function. And now this is an interesting thing. If I go to negative pi, in other words, if I say f of negative pi equals negative 1, guess what? F of positive pi also equals negative 1. So that's where this cosine of a negative x is the same as cosine of x, because it's symmetrical about the y-axis. So basically, the left-hand side of the y-axis mirrors the right-hand side. That's why you have these same values down here. Okay? That changes the numbers a little bit. The fundamental period is still 2 pi, but the x-intercepts are shifted over pi over 2. So your x-intercepts are going to be a multiple of pi over 2. Integer multiple. Odd integers, I should say. Odd integer multiples of pi over 2. And then the minimum and maximum values are 1 and negative 1. And then those minimum and maximum values occur at a multiple of pi, an integer multiple of pi. So it could be a positive or negative. Okay? So plus or minus pi, plus or minus 2 pi, plus or minus 3 pi, so on and so forth. Now what I want you to see, and there really isn't much to write down, is why that happens. So if you recall, sine represents what value on a trig function? If you talk about the x or y value in the unit circle, what does sine represent? The y value. So when I go to draw this circle, there's two things. We're measuring the measurement in radians. So I want you to, I'm going to point out some things on the graph so it makes a little more sense. This is 0. 0 radians. The x-axis represents the measure of the angle in radians. All the way down here is 2 pi. Remember, 2 pi is the fundamental period of both sine and cosine. So as I rotate the circle around, there's going to be a corresponding y value. Just imagine, if you will, there's a right triangle and there's a measurement of the y value. The maximum value for y is right here. Now that's at pi over 2. And that value is going to be positive 1. The reason we call it a circular or periodic function is because as I rotate around, remember, this is the xy plane right here, so the y value right at this point is 0. Well, when does that occur? It occurs at pi, when my angle is pi. It says 3.15, so we're just a little bit past 3.14. So as I rotate around, that's what happens. Okay? Now, if I keep rotating around and around and around, this pattern, this periodic behavior, this circular behavior, just keeps going and going because the y values don't change. It just keeps going and going forever, and I'll show you a full graph in a second. Does that make sense? Okay. Now, if I reset this and we do cosine, cosine is represented by what coordinate point? It's the x point. So right now, x equals 1 when you're at 0 radians. So you still have the same pattern of behavior, but right here, x equals 0 at pi over 2. Over here, x equals negative 1 at pi over 2. And so we have the same type of behavior, the same circular behavior, or periodic behavior. It depends on how the question is formed. We'll say circular behavior if we're referring to something with the unit circle. We'll say periodic behavior if we're looking at the graph of one of the trig functions. So then what does that mean? Well, that goes on forever. So if I go to Desmos, and I graph sine, so if I just say sine of x, that's sine of x. How long does that pattern continue? Forever. Forever. Okay? And you could do that. That's in radians. And obviously, if I come in here and I change it to degrees, then it changes it a little bit. I have to zoom out a little bit, but we'll just leave it in radians because it's easier. So that pattern goes on forever and ever and ever. But from here to here, that's 2 pi. Where's the next one? Well, this is negative 2 pi. So that's what they're talking about, the periodic behavior. Where does the period happen again? Well, if I go 0, 2 pi, 4 pi, so all that information you wrote down, multiples, even integer multiples for sine of the period. Notice that it's always 2 pi, some multiple of either 2 pi or negative 2 pi. Likewise, with the maximum values, it's going to be, well, I got to clear that out actually. So if I go with the x-intercepts where it says multiples of pi for the x-intercept, that's all based on that information that I had you guys write down. That's what that means. All right, so let's turn this off. Let's do cosine. Cosine is a cofunction, and I have to plug in x, but really it's theta, right? So same thing here. This is where the period starts. If I go over 2 pi, 4 pi, 6 pi in the same direction this way. But that's the period. In other words, one full cycle is 1 and up. You go down and up. For the other one, you go up and down and then start to head back up. Does that make sense? Also, same thing with the x-intercepts. Now it's just an odd multiple of pi over 2 for your x-intercepts. Same thing with the maximum values occurring at those numbers. And then for the minimum values, those occur at these numbers. That's what all this information, all the multiple integer things down here. Does that make sense? And so that's what those are. So what I'm going to do is I'm going to just kind of graph both these together. And let me just adjust this real quick. We're going to make our y value negative 2 to 2. And let's make this negative 7, positive 7. Okay. So that's what the two functions look like. And you don't have to necessarily sketch it. I just want to leave it in the notes so you guys could see them back to back graphed